Hello everyone, thank you for checking out my video today. In this video, we're going to start talking about how we evaluate logarithmic functions. We're going to talk about some basic log rules again, like we did last time. And then we'll also start talking about where we're heading in the future with some properties of logarithms as well. All right, but to start this, there's a warm-up on the first slide. I showed you the basic rules we learned yesterday. And then there's a warm-up that I want you to try 3 problems. Try those, pause the video, and then come back when you're done. All right, here are your answers to the warm-up slide. Okay, so now let's talk about what we learned yesterday, the definition of logarithm. Logarithm, if we convert from logarithm to exponential, that would be our function. Okay, and they are inverses of each other. Okay, we can verify these 2 functions are inverses because both of these following are true that we learned yesterday. Log base b of b to the x is x, and b to the log base b of x is x. How do we know that? Well, let's rewrite both of these in the other form. So this one would be the base b to the x equals b to the x, which is true. And this one would be log base b of x equals log base b of x, which of course is true. So these 2 functions undo each other, and therefore they are inverses of each other. Okay? Don't look at those second ones yet. Let's try these first 5 together, and then I'll have you try the second set of 5 on your own. So the first one says 7 log base 7 of 5. The 7 log base 7 cancels out, so we're just left with 5. Next one, so we can rewrite this as log base 6 of 6 squared. Log base 6 of 6 cancels themselves out, so our answer here is 2. Third one we can write as log base 3 of 3 cubed to the x. Log base 3 of 3 will cancel out, and we're left with 3x. Fourth one, e to the ln, that's e to the log base e, cancels out, and we're left with 2x. And our last one, we can rewrite this as log of 10 squared to the x. Log base 10 of 10 cancels out, we're left with 2x. Now pause this video and try the next set of 5 on your own. Here's the answers we should have came up with for these 5. All right, next slide, we're talking about finding inverses of log functions. To start, the first step, we do exactly the same we do any inverse function. We switch x and y. But then we want to isolate the log term, and then we want to rewrite that in exponential form. And finally, if necessary, continue to solve for y. Let's take a look at 2. All right, so first thing, we're going to switch x and y. Next thing would be to isolate the log by itself. That's already done. That's already done. The log is by itself right now. So we have log base 4 of y equals x. Now we're going to change it from logarithm to exponential. So 4 to the x equals y. Solve it for y, but that's already done. So our answer is y inverse equals 4 to the x. Next one, switch x and y. Put it into exponential form. So this is base e, remember, so it's e to the x equals y minus 3, and then solve for y. So it's y inverse equals e to the x plus 3. Pause the video again here, and go ahead and try the next 2. And hopefully you came up with these as your answers. All right, let's practice some evaluating. For example, if you said, what is log base 3 of 81? You're going to ask yourself, what power of 3 will give you 81? Well, 3 to the 4th would give you 81. So log base 3 of 81 would be 4. Log base 2 of 32. 2 to what power would give us 32? That's what this question is asking. 2 to what power? So that would be 2 to the 5th. So therefore, log base 2 of 32 is 5. Because if I change that into exponential, that would be true. And you could think of it that way as well. Like for this problem, I could call it equal x, and I could say 6 to what power would give me 1/6? 6 to what power would give me 6 to negative 1? So therefore, my answer is negative 1. 2 to what power would give me 512? This is a tough one. Just, take your time with it. 2, 4, 8, 16, 32. That's 5. 64 is 6. 128 is 7. 256 is 8. And therefore, 512 would be 9. 3 to what power would give me 1/9? So 3 to what power would give me 3 to negative 2? Negative 2. 8 to what power would give me 2? So 2 to the 3x would give me 2 to the 1. So 3x equals 1. Our answer is 1/3. 10 to what power would give me 1,000,000? 10 squared is 100. 10 cubed is 1,000, so forth and so on. So this would be 10 to the 6th power. ln of e to the 7th, well, that's just 7. Because remember, that's e to what power would give you e to the 7th. Log base 5 of 5 to the n, that's just n. And log base n of n to the 5th would be 5. Question J, why is it impossible to evaluate this log? Well, if I did this, 2 to no power will give me negative 8. So that's it. We can't do anything with that. All right. Question 2, without using a calculator, estimate the value between two consecutive integers. Okay. So log base 2 of 40. Well, I know 2 to the 5th is 32, and 2 to the 6th is 64. So my guess would be 5.2. Is there a right or wrong answer to this? There isn't. We're estimating. As long as your answer is between 5 and 6, it would be correct. 3 to the 40th. Well, I know 3 to the 3rd is 27. 3 to the 4th is 81. So this is going to be 3 point something, maybe 3.3. Two to the 1/3. Okay, so 2 to the 1/3. So 2 to the 0 is 1. And 2 to the negative 1 is 1/2. 2 to the negative 2 is 1/4. So I know it's between these two. So we'll say maybe negative 1.5. It's a fair guess. 10 to the 300th. So I know 10 to the 2nd is 100, and 10 to the 3rd is 1,000. So it's between those. Let's go 2.3. 10 to the 0 is 1. 10 to the 1 is 10. So it's between those. Let's go 0.4. Next one. So this is, we can write this as log base 10 of 3/100ths, right? So 10 to the 0 is 1 again. 10 to the negative 1 is 1/10. And 10 to the negative 2 is 1/100th. So it's almost negative 2. So we'll say negative 1.8. I think that's a fair guess. All right, now it says use your calculator to evaluate these. All right, so we're literally just going to be typing in a couple different things here to estimate these. When you do this, we can just think of 2 to what power would give me 40. So you can say, 2 to the 4th, 2 to the 5th, 2 to the 6th. Just get your best estimates here. Again, it should be 5 point something. And you can just kind of play around with your calculator until you really have a good handle on it, okay? There's no way, well, some of the new calculators have a way of actually evaluating this. A lot of the older calculators don't, unless we learn something else, which we're going to learn soon, called the change of base formula. So do your best with these, take guesses, whatever you get is fine. It should be pretty close to where we're at in the last slide. And the last slide, I'd like you to pause the video one last time, evaluate these 10 problems best you can. When you're done, come back and check the answers. All right, here are the answers you should have got for the last slide. All right, these connections that we're making here hopefully are what we're going to be talking about next couple days when we start doing properties of logs. But that'll do it for today's video. I hope you enjoyed it. We'll see you again real soon.